Give me a minute. Yeah. So very good afternoon to all of you. Good afternoon, good evening. So today we are going to start a new chapter. Okay, which is called as amines. So here we study about the organic compounds which contains hydrogen. Okay, so the other name of this lesson can be organic containing nitrogen. Okay, so let's enter into this lesson. So we will try to finish this lesson as soon as possible. So the topics that we are going to cover in this lesson are the structure, classification, and the nomenclature of amines, preparation of amine, physical properties of amines, chemical properties of amines, and at last we have one small topic called diazonium salts. Okay. So in that diazonium salts part, we will discuss the preparation of diazonium salt and some chemical reactions of diazonium salt. Okay. So altogether, this lesson is small lesson only compared to other organic chemistry lessons. Okay. So like aldehydes and alcohols lesson and all, if you see, it is little bit big. Okay. Now this amines lesson is not lesson is not that much big. It is very small. So we'll try to complete this as soon as possible. Got it? So first, let us enter into the first topic, which is called the structure of amines. Okay, structure of amines. Somebody is asking me to record the session. May I know who it is? Okay. Yeah. Before moving on to the structure, I would like to give one thing to you, one statement to you. What are amines basically? Amines are the derivatives of ammonia. Okay, amines are the derivatives of ammonia. So we all know that the formula for ammonia is NH3. So if you replace any of the hydrogen by an alkyl group, am I not audible? For JNB Nagun? Guys, what about others? What about, am I audible, students? Can you able to hear my voice? Bhagat, Aishwarya, Dishan, Madhukar, Parveen, Rohit Mugilan. Am I audible? Can you able to hear my voice? Genuine Nagun students are saying that I am not audible to them. Not audible? Audible, right? Okay. Okay, fine. Then Genuine Nagun, please check your network connection. Please check your network connection. There is an issue from your side, so rectified. Yeah, let us discuss. So amines are the derivatives of ammonia. So ammonia is NH3, and if you replace one of the hydrogen by alkyl group, alkyl group means methyl, ethyl, propyl, those compounds are alkyl groups. Okay. So if you replace the hydrogens by the alkyl group, you will end up with different types of amines. Okay. So here I am going to talk about the structure of amines, and after this we will discuss about the classification of amines. In that classification, I will discuss everything in detail regarding the formula. I mean how the amines are getting derived from ammonia. Okay. So talking about the structure, I have taken this molecule where nitrogen is bonded with 3 CH3 groups. Okay. Where nitrogen is bonded with 3 CH3 groups. So this is the structure. Nitrogen is bonded with 3 CH3 groups. Okay. So we all know that nitrogen has 5 valence electrons and 3 of them has been used for bonding, and the remaining 2 electrons are there which will be present as one lone pair. Okay. So this is the structure of this molecule. Now coming to the hybridization of nitrogen. Can anyone tell me the hybridization of nitrogen? You might have studied about hybridization in your class 11, right? In chemical bonding lesson, you might have discussed about the hybridization. What is the hybridization of nitrogen here? Very good, Rohit. It is sp3. Very good, Parveen. So the nitrogen hybridization is sp3. So it has 3 bond pair and 1 lone pair. So the number of bond pair plus number of lone pair is equal to 4. So if the steric number is equal to 4, then the hybridization is sp3. Very good. So if the hybridization is sp3, then the geometry is pyramidal. Right? It is a pyramid kind of thing, no? So as you can see here in this picture, it is pyramidal in geometry. And the carbon, nitrogen, carbon, okay, bond angle, it will be less than 109.5 degree. It is because of the unshared electron pair, which is called as lone pair. So because of this lone pair, and bond pair repulsion, the carbon, nitrogen, carbon, the bond angle decreases from the normal tetrahedral bond angle. Okay, so this is the normal tetrahedral bond angle. So here it should be 109.5 because the structure is tetrahedral. Okay, structure is tetrahedral. But due to the lone pair and bond pair repulsion, this bond, no, it will come closer to the other bond and the bond angle will be little bit reduced. Got it? So all these are the CH3 groups. All these are CH3 groups. The angle that is formed between carbon, nitrogen, carbon is 108. So 108 is little bit less compared to 109. Okay, it is because of the lone pair, bond pair repulsion. All right. So this is about the structure of amines. Clear? Shall I go for the classification? Did you guys take a note of the structure of amine? Hybridization, geometry, and the bond angle. So these are the 3 points you're going to note down from this. Clear? Yeah. So now let's go for the classification of amines. So as I have already said, amines are the derivatives of ammonia. Ammonia is NH3. And if you replace one of the hydrogen by an alkyl group, you will get RNH2 as the formula. Right? RNH2. So this is called as primary amine. Okay? And if you replace 2 of these hydrogens by R group, you will get R2NH, which is called as secondary amine. And if you replace all the 3 hydrogen by 3R group, you will end up with R3N, which is called as tertiary amine. Okay? RNH2 is primary, R2NH is secondary, R3N is called as tertiary. Okay? Good evening, JNV Nagun students. Good evening. So we are discussing about the amines, okay, which is a new lesson for today. All right. So this is about the classification, students. So any doubt from the classification? As I've already said, R is nothing but the alkyl group. Okay. So alkyl means it can be methyl or it can be ethyl or it can be propyl, isopropyl, butyl, it can be anything. Okay. Is it clear to all of you? Shall we go for the nomenclature of amines? Any doubt till this? Isn't that the basics only? Shall I enter into the next topic, students? Yes or no? Okay. So the next is nomenclature of amines. Nomenclature of amines. As you all know, each organic compound has 2 different types of naming, right? One is common name and the other one is IUPAC name. So as usual, let us enter into the common names of some amines compound. Okay. So in common name, you have to use the prefix alkyl and along with that, you have to add a word amine. So alkyl amine is the general name for this common name. Okay, so let me take one compound. So this is a compound. So here the alkyl group is ethyl. So we are having 2 carbon containing alkyl group, right? So it is called as ethyl. So alkyl part is ethyl and NH2 is amine. So what is the name of this compound? Ethyl amine. This is called as ethyl amine. Okay. And coming to the second compound. This part is the alkyl group. So what is this? This is called as isopropyl. Isopropyl. You all should be very, very clear about the alkyl groups. Okay. Methyl, ethyl, propyl, isopropyl, butyl, N-butyl, isobutyl, secondary butyl, and tertiary butyl. So all these alkyl parts you have already studied in your class 11. So if you do not know or if you have any confusion still, you go through that again and then come to this. Okay. Otherwise, it will create a confusion for you. Got it? So if 3 are branched manner like this, then it is called as isopropyl group. So the alkyl part is isopropyl and you have to add amine to it. So the name of the compound is isopropyl amine. Okay. Now here in this third compound you see. So here I have 2 alkyl groups because this amine is a secondary amine. Okay. So in the left side I have an alkyl group where we have only 1 carbon. So it is called as methyl. And here we have 2 carbons. So it is called as ethyl. So we are having 2 alkyl groups here. So here we have to follow the alphabetical order. Okay. So E comes first in the alphabet, right? So the name of the amine is ethyl methyl amine. Ethyl methyl amine. So is it clear? Ethyl methyl amine. Very good, Chandan. Your answer is correct. Now let me go for the fourth compound. So here how many alkyl groups we have? 1, 2 and 3. So the formula is R3N. So it is a tertiary amine. Okay, R3N is called as tertiary amine. And all the 3 alkyl groups are same. So what is the name of this alkyl group? Methyl. All the 3 are methyl. We have 3 methyl. So the name of the compound is trimethyl amine. The common name of the compound is trimethyl amine. Okay. So let us go for the fifth compound. And again here it is an tertiary component. So we have 3 alkyl groups. These 2 are ethyl since they have 2 carbons each. And this one is having 4 carbon. So it is called as butyl. Can anyone name this compound? Can anyone give me the name, correct name of this compound? We have 2 ethyl and 1 butyl. It is not propyl, my dear. It is not propyl. Yeah, it is diethyl. Yeah. Okay. So it is diethyl butyl amine. It is diethyl butyl amine. Okay. Fine. So what about this? Benzene ring attached with NH2. Benzene ring attached with NH2 is called as, name the compound. It is an aromatic amine, right? Can anyone find out the name? Yeah. The name of this compound is aniline. The name of this compound is aniline. Very good. What about this? We have one substitution in this aniline. I will check the name of this compound once again. Okay. I have a small doubt. So let me check this and I will get you back in the next lesson, next class. Okay. The common name I'm asking. Common name you might not be aware of it. So I will give you the common name. So it is orthotoluidine. Okay. The name of this compound is orthotoluidine. one more last compound we will try to do. So here is the compound. We have an alkyl. It is not alkyl. Can you guys able to identify the name of this part? 3 carbon, which has double bond, single bond, and single bond. What is the name of this group? Okay, is it propene? All kind, this propene, ethene, butene, everything has to come in IUPAC, not in common name. Okay, it is not propyl. It is not propyl. Chandan is correct. It is allyl. It is called as allyl. So the name of the compound is allyl amine. Okay, allyl amine. Clear? So this is the common name. This is the common name for some of the compounds. Now let us go for the IUPAC naming. IUPAC naming for the same compounds which we have discussed in previous slide. So the alkyl amine is the general name we have to use in common naming. And in IUPAC naming, you have to use the word alkanamine. Alkanamine. So the E of alkane has to be replaced by amine. Alkanamine. Okay. So what is the name of the alkyl group here? It is ethyl. I mean ethane. Okay. Alkane is ethane. So replace the E by amine. So what will you get? It is ethanamine. The name of the compound is ethanamine. Very good. What about this? If we have more than 2 carbon in our compounds, we have to start numbering, right? And here you can number from left to right or right to left. Any type of numbering is okay because it is symmetrical, no? So we have 3 carbons and to the second carbon, amine is attached. So what could be the correct name for this compound? Can anyone guess and tell me the answer? Yeah. Parveen, you have to remove E from your answer. We are replacing E by amine, right? So the name of the compound is propan 2-amine. Chandan is correct, but he has made some small mistake, I think so. Yeah, spelling mistake. Your answer is correct. Propan amine is the correct answer. Propan 2-amine is the correct answer because at the second position only we have the amine, right? So we have to mention the position of the amine group to which it is attached. Got it? What about the third compound? No problem, my dear. No problem. Chandan, you don't have to. Sorry, Parveen. No problem. So here we have 2 alkyl groups, right? So if we have more than one alkyl group, what we have to do? Ethyl methylamine is the common name of this compound. In IUPAC naming, you have to take one of the alkyl group as the parent chain. Okay. So how will you select? How to select the alkyl group which is coming under the parent chain? So for that, you have to go for the alkyl group which is having more carbons. Okay. So here we have 2 alkyl group. One is methyl and the other one is ethyl. So ethyl has 2 carbon and methyl has only 1 carbon. So ethyl part has to come under the parent chain. Okay. So I have to start numbering, right? Numbering the carbon which is there in the parent chain. So numbering has to go like this. The nitrogen attached carbon should get number 1. Okay. So this is the parent chain. Now this CH3, this alkyl, the small alkyl group is taken as the branch. So this is methyl group. And this methyl is attached to the nitrogen. So it is called as N-methyl ethanamine. N-methyl ethanamine. Can you all able to understand? Any doubt or confusion here? Do you guys have any confusion? Is it clear? Is it clear? All clear. Okay. Okay, then find out the answer for this question. What is the name of this compound? We have 3 alkyl group. So one should be taken as the parent one, parent chain. The other 2 are taken as the substituent. So find out the name of this compound. Keep this in the parent chain. Okay. and the other 2CH3 as substituent. Chandan answer is correct. But we have two methyl groups, right? So both are attached to nitrogen. So you have to mention that also. Very good, Parveen. Correct answer. N, N dimethyl. So two methyls are attached to nitrogen, right? So N, N dimethyl methanamine. Okay. N, N dimethyl methanamine. You should not leave any space in between the names. Okay. So you see here, we did not leave any space, right? You have to write everything, connect everything and write. Don't leave any space between methyl and methanamine and all. So N, N dimethyl methanamine is the complete name. It is one name. So you should not leave any space. All right. So what about for this compound? Okay, my dear. Okay. No problem. So find out the name of this compound. What is the name? N diethyl butanamine. Very good. So in butyl part only we have 4 carbons, which has more number of carbon, and 2 ethyl groups are attached to nitrogen. So it is N, N diethyl butan 1 amine or butanamine. Both are correct only. Okay, so you can denote one or you can leave it. For one, it is an exception. Okay, you can write or you can leave. So N, N diethyl butanamine is the correct answer. And here coming to the aniline, the IUPAC naming of aniline is also just give me a second. Just give me a second, students. I will be back. Yeah, sorry for being late, students. Okay, so what I was saying is, can you all able to hear my voice? I'm audible, right? Am I audible? Yeah. Thank you so much for your kind patience, my dear students. So, in IUPAC nomenclature, aniline can also be taken as benzene amine. Okay, aniline is also written as benzene amine. Okay, so this is one point you have to note down. And here if you see, we have methyl group attached next to NH2. So we have two groups attached to the ring. So this type of compound, if you are having more than one group attached to the ring, you have to number. So obviously, amine is a functional group and amine containing carbon is numbered as one, and here 2, 3, 4, 5, and 6, etc. Okay. So to the second position, to the second carbon, methyl is attached, right? So it is called as 2-methyl aniline. It is called as 2-methyl aniline or 2-methyl benzenamine. Both are correct only. Okay. So let me go for the last compound. So this is a 3-carbon containing allylic system, right? So we have a double bond and we have an amine group. So in the priority list, amine should get the first priority. Okay. So the NH2 carrying carbon should be numbered 1. Okay. Should be numbered 1. So now we have 3 carbons. So it is prop, and between 2 and 3 we have a double bond. So prop 2-ene, and to the first carbon amine is attached. So the name of the compound is prop 2-ene 1-amine. Prop 2-ene 1-amine. Is it clear to all of you? So 3 carbon propene. It is propene. So between 2 and 3 we have a double bond. So prop 2-ene. And E is replaced by amine. Okay. Prop 2-ene 1-amine. No. Double bond. If double bond is bond having a halogen in it, then double bond should get the first preference. Okay. For example, if I have CH2Cl CH double bond CH2. So here I have a double bond and also I have a halogen. Okay. So when you compare double bond and halogen in the priority list, double bond will get the first priority. Okay. Priority list is given in the first general organic chemistry lesson of class 11. Okay. If you go through the list, so there double bond will be the functional group and Cl will be the substituent. So since double bond is a functional group, it should get the first preference. Okay. For halogens, for alkyl, for other things, double bond will get the first preference. But when you compare NH2, NH2 is an amine. Amine is a functional group. So in that case, you have to give the first preference to amines only. Okay. So to get a better idea about this, you please go through the list, priority list of the functional groups. Okay. Clear? Clear? Yeah. Okay. All right. So these are the IUPAC names of the amines. Got it? So do you guys have any doubt from it? Shall we go for the next topic? Shall we go for the next topic? Any doubt from the structure, classification, and nomenclature? So everything clear? Shall we go for the preparation of amines? All right. So moving on to the preparation, we have 5 to 6 preparations of amines. Okay. The very first is by the reduction of nitro compounds. So let me take a nitro compound. Nitrobenzene is the compound that I am taking. So I have to reduce this. Okay. Nitrobenzene on reduction will give aniline, which is an aromatic amine. Okay. So for this reduction, for the conversion of NO2 group to NH2 group, we have to use the reducing agents, right? So the reducing agents are hydrogen in presence of palladium and tin in presence of HCl and iron in presence of HCl. Okay, so these are the very simple reducing agents which will convert NO2 to NH2. Okay, very easy reaction it is. You just need to memorize this reducing agents. That's all. Okay, this is the first preparation. The second preparation is called as aminolysis of alkyl halide. Aminolysis of alkyl halide. So what is aminolysis? So we have to take an alkyl halide or aryl halide. Aryl halides are otherwise called as benzyl halides. Okay. So take any one of these halides and treat it with ethanolic NH3. Ethanolic, alcoholic NH3. Alcoholic NH3. And then you heat at 373 Kelvin. It will produce primary amine and secondary amine and tertiary amine. So let me show you the reaction. So this is ammonia. This is the alcoholic, the ethanolic NH3. Okay. It is treated with an alkyl halide. Okay, alkyl halide will have the partially positive alkyl group and the partially negative halogen group. Okay, now what will happen? Ammonia will act as a nucleophile. So nucleophile means the compound will go attack the electrophile. Electron-rich species will go and attack the electron-deficient species. So since nitrogen is having lone pair of electrons, which is electron-rich, so that is going and attacking the electrophilic part of this alkyl halide. Electrophilic means the positively charged group. Okay, so which is acting as an electrophilic site. So the nucleophile is attacking the electrophile, and the electrons which is present between R and Cl will go to the Cl. So that we will get RNH3 plus, which is called as quaternary ammonium salt, and Cl minus. So since we have plus, it is called as a salt. Since it is coming from ammonia, it is called as ammonium salt. Okay, so nitrogen is having 4 bonds, where one of it is with the alkyl group. So it is called as quaternary ammonium salt. Now, this quaternary ammonium salt is treated with NaOH. If it is treated with the base, one of the nitrogen-hydrogen bond is getting cleaved and HCl is coming out. HCl is coming out, one of the hydrogen, and chlorine is coming out as HCl. So HCl is removed, minus HCl, and the remaining is RNH2. So this is primary amine formula, right? RNH2 primary amine. Then this primary amine will act as a nucleophile and it will go and attack RCl in the same way the ammonia has done. Okay, the ammonia has done. So primary amine will act as a nucleophile through this lone pair of electron, and the reaction goes in a similar manner and it forms secondary amine. Okay, then secondary amine will act as a nucleophile and it will produce tertiary amine. So like this the reaction goes on. So this is called as aminolysis of alkyl halide. Okay, clear? So aminolysis means the breaking of RCl bond by ammonia. Of RCl, this bond is getting cleaved, right? So the breakage or the cleavage of RCl bond by ammonia is called as ammonolysis. Is it clear? Can you all able to understand the first preparation and the second preparation? Any doubt? Any doubt? Any doubt for anyone? Shall we go for the third preparation, students? So Amin's lesson is very easy. Amin's lesson is very easy. So please concentrate and try to learn. Okay? Try to learn properly. You can get good marks. So coming to the third preparation, which is reduction of nitrile. So in the first preparation, I have discussed the reduction of nitro compounds. Now we are going to reduce the nitrile. So what is the formula for nitrile? Can anyone give me the formula for nitrile? The general formula for nitrile? Yes, very good. It is RCN. So we are going to reduce. Reduction of nitrile will give amine. So who are the reducing agents? One among it is hydrogen in presence of palladium. Second is lithium aluminum hydride. And the third one is sodium amalgam with ethanol. Sodium amalgam with ethanol. So you can use any one of these reagents and you can reduce. So during reduction, addition of hydrogen happens, right? Addition of hydrogen is called as reduction. So in this triple bond, first you break one of the bond and add hydrogen like this, and break the second bond and add hydrogen like this. So at the end, we are having RCH2 bond NH2. Okay. So from the nitrile, we are getting the primary amines. From this particular nitrile, we are getting the primary amine. Okay. So now the fourth preparation is reduction of amide. What is the formula for amide? What is the formula for amide? Can anyone tell me? The general formula for amide. Is it RCONH? It is RCONH2. RCONH2. So you have to take this amide and you have to reduce it. So the reducing agent which will reduce CONH2 is lithium aluminum hydride in presence of water. Okay. So here when you treat this amide with this particular reagent, the C double bond O group will be converted to CH2. Okay. And primary amine is formed from this. Primary amine is formed from this. Okay. Very easy. Lithium aluminum hydride in presence of water will convert the normal amide to amine, where the conversion of CO to CH2 takes place. Okay. So now let's go for the fifth preparation. Fifth is Gabriel thalamide synthesis. Gabriel thalamide synthesis is a naming reaction. So you have to give more importance to this. Okay. So here you have to take thalamide as the starting compound. Thalamide. This compound is thalamide. A benzene ring, phenyl ring attached to COCONH is called as thalamide. And this thalamide first has to be treated with KOH. Okay, it has to be first treated. If you treat it with KOH, the potassium H2O will come out. Potassium will take the place of this hydrogen. So we have K minus and N minus and K plus. Then you have to treat it with RX. You have to treat it with RX. So when you treat it with RX, the KX will come out and R will go and take the place of K. Okay. So here nitrogen is attached with R group, alkyl group. Then thirdly, you have to take aqueous NaOH and H3O plus. Aqueous NaOH and H3O plus. So this will lead to the formation of phthalic acid and a primary amine. So what is happening here? The carbon-nitrogen bond will get cleaved. Bond will get cleaved and here 2 moles of NaOH will react. So NaOH has ONA and H, right? ONA and H. So here what happens? The ONA will go to the carbon and H will be added here. And here also ONA will go to the carbon and H will be added here. So finally we have RNH2 as one of the component, which is the primary amine formed here. And after doing this hydrolysis, the ONA will be converted to H. So by that only we are getting this phthalic acid. So this is the byproduct only. The main product is the primary amine. Okay. So this is the very good method. Gabriel thalamide synthesis is a very good method to form the primary aliphatic amines. Primary aromatic amines cannot be prepared by this method. Aromatic amines cannot be prepared by this method. This point is a very important point. Please take a note of it. Okay. So this is the best method to prepare the primary amine, but only aliphatic primary, not aromatic primary amine. Clear? Any doubt from this reaction for anyone? Thalamide will be converted to phthalic acid. So the name of the amine, okay, the name of the amine is based on the R group which we are taking here. All right. Students, is it clear? Fine. What about others? Aishwarya, Bhagat, Chandan, Jainvi Kadapa, Nagun, Piali, Sivamani, Parveen. What about you guys? Staying so silent. Can you able to understand this Gabriel thalamide synthesis? Shall I go for the last preparation of amine? Okay. Okay, Bishan. So the very last preparation is Hoffman bromamide degradation reaction. So here you have to take amide. So it is amide, right? Bromamide. So you have to take the component, one of the component as amide. Since it is a bromamide, the second component is bromine and the third component is sodium hydroxide. So 1 mole of bromine will react with 4 moles of sodium hydroxide with amide and they lead to the formation of an amine and Na2CO3, 2NABr and 2H2O. Okay. So what is happening here? The C double bond O is going out and we are left with only RNH2. We are left with only RNH2. So in one of the previous reaction, if you have noticed, I mean, in the fourth preparation also we have used amide only. But we have taken that amide and we have treated that with lithium aluminum hydride. Right? We have treated this with lithium aluminum hydride with H2O. And they led to the formation of RCH2O, NH2. Right? So here the number of carbon remains same. But here in this Hoffman bromamide, you see, we don't have the carbon here in the product. So one carbon less amine will be formed from this reaction. Okay, Hoffman bromamide is also one of the very important reaction where one carbon less containing amine will be formed from the amide. Is it clear? This is the very important one you have to keep in mind. Any doubts, students? Shall we go for the physical properties? So these are the 6 methods of preparation of amine from different compounds. What is the first one? First is the reduction of nitro compound. Second is aminolysis. Third is from nitrile. Fourth from amide. Fifth from phthalimide. And sixth is Hoffman bromamide degradation. All right. So now let us enter into the physical properties of amines. So the very first physical property that I'm going to take is the boiling point of amine. So you all should listen properly. Okay. So if the molecular mass is less, then the boiling point is more. This is the relation you should know. If the molecular mass is more, the boiling point is more. Sorry, dear students. Boiling point is directly proportional to molecular mass. Boiling point is directly proportional to molecular mass. If the molecular mass is more, boiling point will also be more. Okay, this is the relation you should know. Then, the second point is the primary amines will have the highest boiling point value compared to secondary amine. Secondary amine will have the highest value compared to the tertiary amine. Okay, why? Why it is like that? I will give you the reason in the next slide. So before that, I would like to give one more point. The comparison of boiling point of some organic compounds with similar molecular mass. Some organic compound with similar molecular mass. Okay, so I'm going to take some organic compounds. Those are alcohol, primary amine, secondary amine, tertiary amine, and then hydrocarbon. So hydrocarbon means alkane. RH is called as alkane. And this is the tertiary amine, this is secondary amine, and this is your primary amine. Here it is the alcohol. So these are some of the organic compound which has same molecular mass. But if you look into the order of boiling point, alcohol is having the highest value in terms of boiling point. You all know, right? You all know the reason, right? So alcohol is having the highest boiling point because of hydrogen bonding. Because of hydrogen bonding. Okay. Only because of hydrogen bonding, alcohol is having the highest boiling point value. And the next one is primary amine. Primary means RNH2. So in case of primary, 2 hydrogens are there. So there will be the formation of 2 hydrogen bonding for 1 molecule of amine. When you go for the secondary amine, we have R2NH. We have R2NH. And here we have only 1 hydrogen. So only 1 hydrogen bonding is possible. Whereas in case of tertiary, no hydrogen bonding is possible. So if the number of hydrogen bonding is more, then the boiling point is more. So that's why primary amine is having the highest boiling point compared to secondary amine and then tertiary amine. Okay, alcohol is having highest value because of the strong hydrogen bond that it will make, okay, with the other compounds. So this is about the boiling point of amines. I hope it is clear to all of you. Okay, if you are having any doubts, please let me know. The next one is the basic character of amines in terms of Kb value. So Kb value determines the basic character. We have two different characters, right? Acidic character and basic character. So from the Kb value, we can find out whether the given amine is basic or acidic. But how? What is the relation? If the Kb value is greater, pKb value will be smaller. Okay, if the Kb value is greater, pKb value will be lesser, smaller. So if it is like this, then the base is a strong base. So Kb value is determining the basic character. Means Kb is directly proportional to basicity. Kb is directly proportional to basicity. If the Kb value is greater, then your base is your amine is a strong base. Your amine is a strong base. Here you see in this list. If the pKb value is lesser, then base is a strong base. So the one which is having the least pKb value will be more stronger. So in this, here you see, it is the decreasing order of pKb. Okay, decreasing order of pKb and increasing order of basic strength. So among these molecules, the last molecule, N-ethyl ethanamine is having the least pKb value. So obviously that is the strong base compared to the other. Okay. So you see the highest value of pKb is given to benzene amine. What is this benzene? Who is this benzene? It is aniline, right? So C6H5NH2 is benzene amine. It is an aromatic amine. But N-ethyl ethanamine is an aliphatic amine. So if I compare an aromatic amine with aliphatic amines are more basic compared to aromatic amine. Okay. Aliphatic amines are more basic compared to aromatic amine. Is it clear to all of you? Is it clear to all of you? Shall I go for the next concept? Next physical property. The first physical property is the boiling point. Primary amine will have the highest boiling point because of hydrogen bonding. So when I compare the boiling points of different compounds with same molecular mass, alcohol will take the first preference and then primary amine. Okay. Then the third point is about the basic character. Aliphatic amines are more basic compared to aromatic amines. Okay. So where Kb is directly proportional to basicity. Shall I go for the next term? Shall we go for the next property? In the next property also we are going to discuss the basic strength only. But the basic character or the basic strength of amines in gaseous phase. Okay. To understand this, I am going to take ammonia and then I am going to compare that ammonia with amine. Okay. So this is ammonia. Ammonia formula is NH3 with one lone pair. If I treat this ammonia with H+, the lone pair which is present on ammonia is going and attacking the H+, and it is forming NH4 plus ion, which is the conjugate acid of ammonia. Okay. Now,
Hello?
instead of ammonia, if I take amine, if I replace one of the hydrogen by R group, it is a primary amine, right? So if I put primary amine with H+, then again, the lone pair will go and attack the H+, and it will form the conjugate acid. But in case of alkyl group attached amine, alkyl group is an electron donating group. So it will donate the electrons to the positively charged nitrogen and makes the system more basic. Makes the conjugate acid more basic. Okay, here positively charged means it is electron deficient. Okay, electron is very less. And next to it, electron donating group is there. So electron is already less here. And one person is there to help. by giving its electron. So what will happen? The basicity will increase. If a compound is more electron rich, then it is called as a strong base. So the order of basic strength will be like this. Tertiary amine is more basic, or ammonia is less basic compared to primary amine. Primary amine is less basic compared to secondary. Secondary amine is less basic compared to tertiary. So why it is like this? So here we have 3% is there to help, and here we have only 2% to help, and here only one alkyl, only 1% to help the nitrogen, and here we don't have anyone to help it out. Okay. So if we have more number of people who is helping us, then we become more electron rich and the basicity will be more. Clear? So this is the basic strength in gaseous phase. This is the basic strength in gaseous phase. Is it clear? Any doubt for anyone? Shall I discuss the basic strength in aqueous phase? Shall we go for the basic strength in aqueous phase? Yes or no, students? Basic strength in aqueous phase. Any doubt from the previous slide? Okay. Now here in case of aqueous phase, we have water, right? So water is there, obviously hydrogen bonding will be existing there. So the extent of hydrogen bonding in water and the order of stability of ions by solvation determines the basic strength. The extent of hydrogen bonding and the order of stability of ions by solvation is determining the basic strength. So first let me take the primary amine. So this is the primary amine. The hydrated, the protonated amine I can say. The protonated primary amine. Okay. So here if primary amine is put inside the water, the hydrogen will go and take the H2O molecule. So we have 3 hydrogen in primary amine. So it will go and form the bond with the water. Okay. So it will be more basic. In case of secondary amine, only 2 hydrogens are there. So only 2 hydrogen bonding can be formed. And in case of tertiary, we have only 1 hydrogen. So only 1 OH2. The only 1 water molecule can come and form the hydrogen bonding with the tertiary amine. Okay, so I am taking the protonated amines. Okay, protonated amine. And 3 molecules of water is coordinating with primary, 2 molecules is getting coordinated with secondary, and 1 molecule is coordinated with tertiary. Okay, so now from this is called as solvation. This is called as solvation. Okay, primary amine is having the highest stability because of the 3 hydrogen bonding. So it is having the highest strength. So the overall order of basic strength will be like this. NH3 is a, listen, NH3 is least basic, and then we have tertiary, then we have primary, and then this is the secondary part. So this is the order you have to follow if the alkyl group is the methyl group. Okay. So this is the order you have to follow if the alkyl group is the methyl group. Okay. Very, very important question it is. So if the methyl group, if the alkyl group is methyl, then secondary amine will be more basic compared to primary and then tertiary. Instead of methyl, if I have ethyl substituted amine, if I have ethyl substituted amine, then in that case, the secondary will be more basic, then tertiary, and then primary, and last ammonia. So these 2 orders are very, very important. Methyl substituted amine and ethyl substituted amine. So they are following different orders. So till last lesson, we have some regular kind of pattern in writing the basic strength or acidic strength or boiling point, etc. Right? But here, some irregularities are shown. It is because of some reasons. So one among it is steric reason, and the other one is the solvation effect and inductive effect. So one reason in the sense inductive effect in one case will dominate the solvation effect. Okay. So likewise, the one effect will overcome the other and they will lead to the different orders. Okay. So for methyl and ethyl, you have to follow this order because it is given in the book. All right. Clear? Do you guys have any doubt? You don't have to worry about the reason for this. Just memorize. If methyl is attached, secondary, primary, tertiary. Ethyl is attached, secondary, tertiary, primary. That's all. So this is the thing that you are going to do. So don't worry about the reason why it is like this and why it is like that and all. Okay. Yeah. So this is enough for today. So in the next session, we will discuss the basic character again. But there I will discuss about the effect of substituents in basic character. Okay. So what will happen to the basicity if some substituents are attached to the ring, to the aromatic ring. All right. So I hope today's session is clear. Do you guys have any doubt from today's session? Do you guys have any doubt from today's session? Shall we go? Shall we wrap it up the today's session? Okay, students, thank you so much. See you all in the next class. Take care. Bye-bye.